All right, folks, day 5, end of the first week. It's only been 1 week. It feels like it's been an entire month that we've been doing this remote learning thing. I'm getting a little bit of cabin fever here. All right into the lesson. So this is the exit ticket from yesterday's Google form. Not necessarily drawn to scale, but the whole approach here was you needed to find some information about the part of this parallelogram before you can find both the perimeter and the area. So they were given the diagonal and the opposite angle here and one side of the triangle. Now this is technically side angle. I'm going to tell you right now, spoiler alert, there's only one triangle possible here. You're not going to need the second one just for convenience sake. I mean, if you want, if it's good practice, you can actually show that there's only one triangle. However, the triangle that I'm solving for is the only one possible. So the trick here is I want this side length, the side BC here, or according to the small triangle, side A. And in order to do that, I would need to know angle A. And in order to get angle A, I'm not going to call this C because C would technically be the entire triangle, or the entire angle here. So I'm just going to call theta, which is the little wedge of the lower triangle angle. So we're going to find theta first, setting up a law of sines. The sine theta over the opposite side, 12, equals sine 65 over the opposite diagonal, 25. Cross multiplying and solving for theta, you get, and this is a little bit rounded, 25.8 degrees. Well, back to the triangle. If this is 25.8 and this is 65, subtract from 180, and now we can get this angle here, which would be 180 minus 65 minus 25.8 is about 89.2. So now using this angle as 89.2, we can use another series of law of sines and solve for finally side A. So, well, there's my son. He just got back from his walk. A over sine 89.2 equals 25 over sine 65. Cross multiply, divide, however you need to solve for A. You get about 27.6. So that's not done because that's not the perimeter nor the area. The perimeter is pretty easy. It's a parallelogram, so we know opposite sides of this are going to be equal. So if this is 12, this side's going to be 12. A would be 27.6. That's 27.6. Total perimeter is 79.2. All right, I think I took crisis averted downstairs. So I think I finished up with the perimeter area of this triangle. I'm going to use my 1/2 AB sine C, or really in this case 1/2 AC sine B formula. This inside the brackets here only gives me this triangle, but these two are going to be congruent. That's why I'm multiplying it by 2. And that comes out to be about 300.2. Now, I'm going to move ahead a little bit in section 4.2. I'm going to keep today's lesson, the new material part of it, pretty short. It's a pretty easy formula. If you took a look at your formula sheet today, or excuse me, yesterday, because you're going to be watching this tomorrow, you probably already saw this formula on the list. This is called Heron's formula. Heron was a really old Greek guy about 3,000 years ago. He derived this formula. It's pretty famous. This gives us the area of any triangle that we know the 3 sides for. So it doesn't have to be a right triangle. It doesn't have to be isosceles or equilateral. Any triangle. This formula works for all of them as long as it's a side situation, meaning we would be given all 3 legs of the triangle. So the area is pretty simple. It has this new term S, which stands for the semi-perimeter. It's basically half of the perimeter. So because we would be given all 3 sides, we know what the perimeter is. Half of that is your semi-perimeter. That gives us this value S. So the square root of S times S minus A times S minus B times S minus C would be the area of this triangle here. So just a quick computation here, or a quick example. If I want the area of a triangle, and these 12, 16, 24 are the three sides, the first thing I'm going to do is figure out my value s. So 12 plus 16 plus 24 all over 2. That's going to give us a 52 divided by 2, or 26. So then area would be square root of 26 times 26 minus 12 times 26 minus 16 times 26 minus 24. Okay, as long as each one of these is in their sets of parentheses, it doesn't matter which order you put them in, because they're all going to be multiplied eventually anyway. And I had it. It is the about 85.3. Keep in mind its area, so it's going to be units squared, in this case feet squared. Okay? You guys are probably curious, because we are starting a new section. At some point in the middle of next week, I'm going to try and give a mini quiz. I do want to do a couple of these in the next coming weeks. I don't really know how long we're going to be doing remote learning for, but I have to give you some types of grades for it. So be on the lookout for, I'm thinking Wednesday-ish, probably Thursday at the absolute latest, but more likely Wednesday, for a quiz of some kind. I'll talk more about it next week on 4.1 and 4.2. So that being said, if you guys have any questions on any of this material, homework, exit tickets, stuff like that, just keep the communication coming. 99% of you guys are doing a fantastic job at that. I mentioned that yesterday, and I'm echoing it again today. Just keep it up with the questions. So that's the best we can do to navigate through these remote learning processes. All right, enjoy your weekends. Wash your hands, be good, be safe.